All right, we're given this polynomial here. It's x to the fourth plus 3x to the third minus 6x squared minus 6x plus 8. And our job is to find all the rational zeros. And so if we're trying to find the zeros, really that's setting our equation equal to 0. So what we've learned previously or in previous classes is that we would try and factor this polynomial, but we don't have any method, like we can't factor by grouping, it's not a trinomial. And so what we've been learning is that we can use synthetic division and use the theorem that says that possible rational zeros are of this form. They're the factors of the constant divided by the factors of the leading coefficient. So for this particular problem, our constant term is the 8, and our lead coefficient is really this one right in the front. And so if we want to list the factors of the constant, well, 8 is, let's see, its factors are going to be 1, 2, 4, 8, and then also they're the negatives of that. So a short way to write that is plus minus, plus minus, plus minus, plus minus, and so it's just like kind of, again, a simpler way of writing that. Now we need to divide those by the factors of the leading coefficient, which is actually really nice here. It's just 1, so we're just going to have plus and minus 1. So this list, again, of just possible rational zeros comes out to be really 1, 2, 4, 8. I'm taking each of these numbers, dividing by a positive down here. And then their opposites. So negative 1, negative 2, negative 4, negative 8. So again, these are just possible zeros. If we want to check if they are a 0, then we're going to use synthetic division. So I'm just going to test a 1. There's not really like a best way to like narrow down your options exactly. So I just kind of play around with it. So I'm going to just try one first and hope I get lucky. So I'm going to put a 1 here and then my leading, or all my coefficients actually, from this polynomial. So we're going to have a 1, a 3, negative 6, and 8. So 1, 3, negative 6, and 8. So again, my goal, what I'm trying to look for, is to have a 0 as my remainder. Then that would tell me that 1 is a 0. So synthetic division says drop this guy down, that's 1. Multiply, put that down here, so 1 times 1 is 1. We're going to add these together to make 4, and then can repeat that procedure. So we're going to get 4 times 1 is 4. Combine that, that's negative 2. We get a negative 2 here. That's negative 8, and woohoo, we're lucky. Our first one, we got a 0. Awesome. So again, what that means is 1 is a 0. And so that tells us also that x minus 1, notice it's the opposite, is a factor of that original polynomial. So x minus 1 times the polynomial represented here, those are our coefficients. Remember, it goes our constant term, our x squared, and x cubed kind of goes up. So we're going to have a 1x cubed plus 4x squared plus minus 2x. Get that in here right. Minus 2x minus 8. And so that is still that polynomial p of x. We just started factoring it using this new method. So now I have 4 terms left over here. And I can do this process again, which I noticed in Alex, it does another test like that. But the other thing that you could do is see if you could factor it by grouping, because I have 4 terms there. So I'm going to take out x squared out of these first 2. We left with x plus 4. And then these guys have a negative 2 in common. I'll be left with x plus 4. And since these factors match, I'm going to write this as x plus 4 times x squared minus 2. So again, this is just regular factor by grouping. Now, if it could not be factored by grouping, you try and you can't find these factors to match like that, then you'll have to do synthetic division again for this polynomial. And so that's like kind of the process. So then x minus 1 comes down. And so we've factored it. Now again, we're just trying to find the zeros. So this is factored pretty good. We have that x minus 1 will be 0, x plus 4 will be 0, or x squared minus 2 will be 0. So we already know 1's a 0. Here's where we get negative 4 is a 0. And then to solve this guy, it's a quadratic, has an x squared on it. We're going to take the square root of both sides, which gets us x equals both the plus and the minus, because anytime you take your own square root, you get plus and minus, and square root of 2 can't reduce, so we just write it as radical 2. So then these are all of our zeros. We have 4 zeros, which again should make sense because it was a polynomial of degree 4. Now the question said to only find rational zeros. So rational is always like pretty ones. So if you look back, these are all of the zeros, but these guys are irrational. Since they don't come out of the square root, they're not the pretty numbers. And so the only rational zeros that we actually have for our function p of x are going to be the 1 and negative 4. So that would be your answer for this question. Hope that helps.